Hey there. Okay, let's take a look at some history and where matter came from and how kind of chemistry got started. So take your notebook and turn to page 3, right, where it says developing models of matter. Boom, like that. There we go. Okay. So chemistry is a science that studies matter. Okay, and what is matter? Matter is anything which has mass. Okay. Note, mass and weight are not the same thing. Okay, we often say, oh, how much do you weigh, or how much does your dog weigh, or whatever, but we actually are talking about its mass. Okay, something with mass takes up space or volume. Okay, weight is how much gravitational force an object has. For example, a textbook has mass, therefore it is made up of matter. But what is matter made up of? That's what we're going to find out. So here is a general timeline that we're going to follow. And I had this presentation and I tried to record it 3 times and it didn't work at all. So I'm just going to do it this way instead. Okay? So this is kind of where we're going to start at 450 BC and make our way to about 100 years ago. Okay? So just to give us an idea of where things have come about. Okay? So about 450 BC, there was a Greek scholar named Empedocles. Okay? And he said that matter was composed of 4 elements: earth, air, water, and fire. Okay? So your desk would be a certain percentage of earth, a certain percentage of air, a certain percentage of water. Your food might be composed of earth and part air. So everything was just made up of these things, which we obviously know is not true. Okay? The elements were mixed in different proportions. Okay? And they make up different substances. He tested some of his theories using experimentation. Okay, which is important because lots of people, their ideas were based on theories or observations, not experimentations. That's really important. Okay. Then about 400 BC, there was a Greek scholar named Democritus. Okay, and he suggested that matter was made up of tiny particles that could not be broken down. He called his particles atomos, okay, meaning indivisible. Okay, do you notice anything inside that word there, atomos? Do you see the word atom? Okay, cool, I'm sure you did. Okay, but his theories weren't widely accepted because Socrates didn't accept them. Socrates was the big cheese at the time, and what he said went, okay? But Democritus was on the right track. Let's turn the page. Okay. 300 BC, there was a Greek philosopher, another guy, there's lots of them, okay, called Aristotle. And I'm sure some of these names will sound familiar to you, okay? And he also accepted the 4 model theory. Okay? His writings influenced people for 2,000 years. I think that's crazy. Okay, so from 1500 to 1600, or from 500 to 1600 AD, there was a group of people called the alchemists. Okay, go alchemists. Okay, so they tried to make gold from cheap metals. Okay, they were the first ones to use a system of chemical symbols, which is pretty cool. And they also invented many laboratory tools and processes that we still use today, like beakers and filters and stirring rods. Okay, They also believed in the 4-element model. Yet no one turned lead into gold. Surprise, surprise. Okay, then in 1650 AD, there was an English scientist named Robert Boyle. Okay, and he said that an element is a pure substance that cannot be broken down into simpler substances. Okay, he didn't believe the 4-model theory. Okay, and he also believed that air was not an element, but rather a mixture, so made up of lots of different things put together. Okay, so he was more thinking along the lines of Democritus. Okay. Then in the late 1700s, 2 guys came along. One was Joseph Priestley. Okay, and he was the first person to isolate oxygen scientifically. And then there was another guy called Cavendish. Okay, and he discovered hydrogen. Okay, so he found out that when hydrogen was burned in the air, water was produced. Well, that's interesting. Okay. When hydrogen was burned in the air, water was produced. And this is also a lab that we do in grade 10. Okay. Cavendish mixed metals with an acid to get hydrogen. Not that he knew that it was an element, but he knew it would burn when mixed with oxygen, producing water. Up until then, everybody thought that water was an element, which we know is not true. Okay. 1808 came an English chemist named John Dalton. Okay, and he developed the atomic model. We also call that the billiard ball model, okay, just like a pool ball. Okay, so he said that all matter is made up of atoms, which are particles that are too small to see, and each element has its own kind of atom with its own particular mass. Okay, compounds are created when atoms of different elements link to form molecules. Okay, atoms cannot be created or destroyed or subdivided in chemical changes. Okay. Continuing in the 1800s came a guy called Michael Faraday. Okay, and he developed a new model. He used static to show that matter contains positive and negative charges. See, I told you that electricity would come and mix in with chemistry. Okay, so he used electric current to form charged atoms called ions. Okay. He discovered that tiny charged particles can be separated from their atoms and moved to other atoms. And what are those particles called? Electrons. Okay. Matter must contain positive and negative charges. Opposite charges attract, and like charges repel. Okay, and atoms combine to form molecules. Okay, so I'm not worried, I'm not interested in you memorizing dates and everything like that. I do want you to get the general gist of how things have progressed, and then you're going to get to know a few specific guys better and their discoveries, okay? In 1904, we have J.J. Thomson. Okay, and he revised the atomic model even further, and he called his discovery, let's change that into a Y, he called his discovery the raisin muffin model. Okay. He said that atoms contain electrons, and that electrons had a small mass, so true, and that the rest of the atom was a sphere of positive charges. The electrons are embedded in the sphere, so the atoms are neutral. So if you had a muffin with 20 protons, okay, the electrons, like the raisins, would be embedded in the muffin and make everything neutral. So you'd also have 20 electrons, okay? There was also a Japanese scientist called H. Nagaoka, and he modeled the atom as a large sphere surrounded by negative electrons. So you can see how the atom is kind of progressing with each person, right? And the last one is in 1911, we have a scientist named Ernest Rutherford. Okay, and he performed a gold foil experiment along with Marsden and Geiger, and they discovered that there was a dense positive nucleus and that electrons moved rapidly around the nucleus. He was amazed and described the gold foil experiment as firing bullets at tissue paper and having one of them bounce back, which would kind of be very scary. Okay? He called his new theory the nuclear model. Okay, so that's kind of a brief history in how matter in the atom has come about. And now I want you to turn to page 7, and you're going to try this activity. Okay, so your task is to make a timeline of how the idea of the atom developed. Okay, you've been given all the information you need to put the timeline together. You will need to do research on the internet using the websites provided to find out which pieces of information go together and find the missing information. You will make 6 different cards, and each card should have the name of the model, the year, the scientist, a description, and a small picture that helps you remember it. Okay? Once you have found which information goes together, glue it to the cards in your booklet as shown, just so you don't lose anything, or you can color code which points belong together or write it in the boxes. Then, using ClassKick, match the information in the chronologically correct order from your timeline. Okay. So on the back side here, it shows all the websites, and I'll have these listed as links in Google Classroom so you can access them easily. Okay. And then here's a list on page 9 of all the information you're going to match. Okay. So if you don't want to cut and paste, that's totally fine. You can, and then glue them in here, or just make your own notes, or just highlight the ones that are supposed to be together. It's up to you, okay? Just so you have your own set, and you'll complete this when you go into ClassKick. Okay, right on.